So here's the project we did with Hélène and me, Robin. So first, let's have a look at the whole program. So we first start with the FCFS algorithm, the function here. So everything is on the same file. Then the SGF algorithm, then R30F, then priority here, and the run robin function here with the run robin with the two function we use for the run robin algorithm. And then we have the main. So here in the main we check what we have in the text file, so the input one, and if the scheduling type is FCFS, we start the FCFS algorithm, everything with the run robin 2, and then we close the output file. So let's have a look at let's have a little demo. So on the console we just start with this line. So now we'll have the test test.exe is here. So test.exe, and then we have the output file here. So we put the input file is the same input file as the spec, and then we have the output here. So 9 the run robin, 10 or so. Yeah, okay. So now I'm going to explain you this function, FCFS, because it's the easiest one. So for every process, so first we sort the array, and then for every process, if the arrival time is still superior at the clock, so clock first it's at 0, we increase the clock, and then clock will be equal to arrival time, so then we add the burst time at the clock, and then we print. So here it's just the arrival time, so we print the clock minus the burst time of the sorted array, then the index of the process, and then the burst time. So after that, the arrival time will be a different one, and the clock will be the first arrival time plus the burst time, and then we increase again the clock until the second arrival time equal to the clock, and then we do it again until the last process. So now let's look at the SGF, so shortest job first algorithm. So it means that we are first sorting the array depending of the burst time here, and we first choose the smallest burst time, and once we are done with this process, we are choosing the next one. So first we check if we have some processes left, and if yes, we are checking if the burst time is equal at 0 or if the arrival time is superior at the clock. And if no, here it's if we are inside of the analysis but we have no process, we still need to increase the clock. Otherwise, if we are inside of the process, so if the burst time of the process is different from 0, we decrease the burst time by 1 and we increase the clock by 1, and the counter is to know how many clock cycles we need to finish the process. Then we increase test hand, and then we check if test hand is different from the size to know if we still have some process, and we output what we want to do with an X at the end, because once we are starting a process we need to finish it before having a new one. Okay, so now let's look at the RTF algorithm. So this is the preemptive shortest job first. So it means that when we are looking for the smallest burst time, we are checking at every clock cycle which process has the smallest burst time. It's different from the shortest job first, because for the shortest job first, when we start a process, we finish the process. So first we need to find at every clock cycle the smallest burst time, so the index of the smallest burst time. So it's a classic algorithm. So first we say that the first one is the smallest, and then we check for all of the array, and if we find smallest burst time, we change the index. So we say that the index of the smallest is now the new one. Then here we check if the index smallest burst time old equal -1. So it means that we want to check if the new oldest smallest burst time is part of the same process, because if it's part of the same process, we don't want to output the lines here. We just want to output the line when we change the process. Otherwise, we'll have a line at every clock cycle. And then we check if the process is done or not, and we output what we want to do. So if the process is done, we'll put this X at the end. Otherwise, we'll put nothing, just a blank space. And then we increase the timer, we decrease the burst time, and we say that the old burst time smallest index is now the new one. So now let's have a look at the priority algorithm. So this is more or less the same algorithm as the SRTF, but with the priority instead of the burst time. So first we need to choose the highest priority, so the biggest one. So we say that the index of the smallest priority is index of the first index, and then we are checking the whole array, and if it's another one, we change the index here. And then if we are inside of the algorithm but there's no process, we increase the clock like before. Otherwise, if we are inside of the process and the burst time is different from 0, we are decreasing the burst time, increasing the clock, the counter, and also the test end to know if we still have some process left. And then we check, like for the SRTF, if the process is done or not. If it's done, we put this X at the end. Otherwise, we put a blank space, and we finish the algorithm. So now let's have a look at the round robin algorithm. So for this algorithm, we need two other functions. So sort queue and find here, and sort queue. So I will explain you this function later. So first, we need to sort the array with the arrival time here, and then so we'll have a queue for the round robin. So index of the queue exec is the index of the queue that we already execute, and index of queue is the index of the queue that we will be execute after. So here, when we choose a new process, we check if the burst time of the index is different of 0, if the arrival time of the index is less than the clock, and also we're trying to find if this process is already in the queue that will be executed after. So with this find her method, so if find her method, the function find her return 1 means that the process is already in the queue that will be executed. Otherwise, if it's 0, it means that it's not in the queue that will be executed. So then we increase the index of queue, and we change the index of the array queue. Then here, sort queue is this function. Is a function who let us know between two processes which one was executed in first, or if one process wasn't executed before, it will let us know that this process wasn't executed before. And then we print what we want, and we check also if the process is done with this X at the end, and we have the round robin algorithm.